Let's relate the inverse to the idea of transformation. We'll start with a theorem. So if A is invertible, it has an inverse, then the transformation AX has an inverse transformation, A inverse times X. Let's do an example. So let's find the inverse transformation of this T. So the first thing we're going to do is find the matrix associated with T, the standard matrix. And if we just read off the coefficients of the variables, we can see that the standard matrix is -5, 9, 4, -7. So we can use our theorem that tells us how to compute the inverse of a 2 by 2. So it's 1 over the determinant. So 35 minus 36. And then you swap A and D. So it's -7, -5. And you flip the sign of 4 and 9, B and C. This works out to be -1 times -7, -9, -4, -5, which just makes everything positive. So now that we have the inverse, the claim based on Theorem 9 is that the inverse transformation is this matrix, this inverse matrix times the vector, which you can write in the form of the initial transformation like so. All right, so let's check our work here. And let's take a vector and transform it, and then apply the inverse transformation and see that we get back to the original vector. So let's just put in 1, 1 into our transformation. So that's going to work to be -5, 9 plus 9, 4 minus 7, and that's going to be 4, -3. And now let's inverse transform this by multiplying this by the inverse, or inserting this into the formula. So we'll do 7 times 4 plus 9 times -3, and 4 times 4 plus 5 times -3. That's 28 minus 27, which is 1, and 16 minus 15, which is 1. So we went from the vector 1, 1 to the vector 4, -3. That vector, that was the transformation. And then we go back with the inverse transformation.